I invite you to break my build. So I want to spend a minute on the reason for the title before we get into the content. I normally don't just jump on and argue with the people on the internet. That's just not what I do. But occasionally you see something that absolutely makes you angry. And one of those was I saw email. This was a few years ago. I saw email coming through to my local user group and from a company that was local. And the email essentially said, do not apply for the job if you have broken the build. Not that I was going to apply for a job anyways, but the minute I saw that, I got very angry. And the reason is having a draconian thought like that is very dangerous. When the company advertises saying, don't apply for a job if you ever broke a build, that to me clearly says that the people who wrote it don't actually build software. And those are some random people who read something and said, boom, here's a big stick and we're going to whack people with it. So that's why I decided to title this as I invite you to break the build. In fact, it's perfectly okay to break the build. So the philosophy I follow is the following. It is okay to break the build, but I would say please do not leave it broken. And that is the philosophy that I like to follow. So it's okay to break the build, but don't leave it broken. Now, what if you tell people you'll be punished if you break the build? Well, if I will be punished if I break the build, there's a very easy way not to break the build, and that is not to commit code. So that means I am going to be very slow in committing code, which is the opposite of what you want me to do. You want me to be writing code as often as I can with good quality and keep committing code. And if I'm going to be reluctant to commit code, if I'm going to hold on to it to make sure that I don't fail the build, then I'm not going to be creative. So to me, it's very important for my team to be creative. I want my team to really move at a reasonable pace and create things. And we have things in measure to make sure that things work really well in production. And that's the whole point of having a continuous integration build. So I want to talk about what can we do to facilitate it. But before moving forward, you could say, oh my gosh, but don't you want the build to really pass? And if the build is failing, that means the person who committed is doing something wrong. Not at all. There are a number of reasons why the code may work locally, but it may fail on the build machine. For example, it's quite possible, in one situation, which I would say probably what you want to avoid is you committed some files and you forgot to commit other files. But that's not the problem I often face. The problem I often face is that the build machine uses a different version of a library or a different version of an operating system or a different version of the database and so on. So there's an incompatibility between those versions coming together that may work very differently on my machine, but works differently on the build machine. And to a great extent, I want my build environment to be different from my development environment as well, but be more close to different environments in production. So if the code would work in one environment, but will not work in another one, I want to know that sooner than later. Well, that's exactly what a CI build can tell you, is that the build running on this environment passed, but the build that is running on this environment failed. I'm like, let me go investigate why it is not working on that environment and try to fix it. So I would say it's if your build never fails, be very suspicious of that and ask why it never fails. This is one of the reasons also, right? We often say when you write test cases, write a failing test and then make the test to pass. Sometimes we don't realize it. I was pairing with a developer on a code, and we wrote the first test. We implemented the code. The test passed. We wrote the second test, wrote the code. The test passed. And we are on to the fifth test, and writing the code, and the test passed. And I paused and looked at my colleague and said, I don't know about you, but I'm never that good. If my fifth test is passing, as soon as I write it, I am beginning to think maybe the test is actually not running at all. And he looked at me and said, well, I was kind of worried about this too, because I am never that good either. So we both said, okay, let's make the test to fail. And we run the test again, and it passes rather than failing. And it was kind of embarrassing. And that's when we found out that the test was not running properly in that environment at all. So if your test never fails, you probably need to be worried that maybe it's not even running properly. But of course, that doesn't mean you want to write failing tests and commit to the repository. That's not the point. But don't be so upset if the build were to fail. That's perfectly fine and natural because of the differences I talked about earlier. And so, and again, one of the other things I'm also very particular about, I am a big fan of, this model, right? The carrot and the stick model. I'm sure you've heard about it, right? So there are times you can give a carrot, and a carrot is great because a carrot is a positive motivator. Hey, if you do this, you can have this carrot. And I like carrots, right? So I'm like, I can work for that carrot that's motivating. The stick model is, I'm punishing you because you didn't do it. And I'm not a big fan of the stick, because when there's a stick on your mind, you are worried about the stick falling on you. And what can I do to avoid being punished rather than what can I do to improve what we are doing? The mindset becomes very different. So I would rather have carrots rather than sticks in my team. So in that regard, one of the fundamental things I always want to think about is to make sure that we treat ourselves, that is ourselves as individual and the rest of the people on the team, with a good amount of respect. So if we start saying, oh my gosh, if you break the build, we're going to shame you in front of the team, that is never a good idea, because what we are trying to do now is trying to make people very defensive, trying to make people very overly cautious, and in an environment where you want a culture where it's actually good to make mistakes. Because if we don't make mistakes, we are not going to be creative. We're not going to go try new ideas. So it's important to promote a culture where, and make a mistake or a failure, not because we don't learn about good qualities or we trash the code. That's not the type of failures I'm talking about. But you're genuinely doing things and you have some failures. That's fine. We learned from it, and it gave us an opportunity to improve what we do. So that should be the culture in the team, is it's okay to fail as long as we can learn from the failures, and hopefully the failure is not fatal, right? So essentially, that's a good culture to build as well. So let's talk about these things in the context of software development. Well, we all talk about agile development. So I'm going to ask the question, what is agile development? And to me, the word agile development only means two different things in particular. So the very first thing for me is agile, I would say development is equal to, I'm going to say, feedback-driven development. So it's feedback-driven development. That's basically what agile development really is. It is feedback-driven development. Any JavaScript programmers in the room? Oh, a few. Sorry, I didn't realize it. Okay, there you go. Okay, so agile development is feedback-driven development, right? So that is basically what you are really after, is that you want to make sure that you work on the feedback and you continuously improve on it. But why is this? The reason for this is we almost never can understand everything that's being communicated. Communication is hard. We may not convey everything that's needed. Now, in terms of development, how do you get really good feedback? Well, if you read almost any book or tutorials on agile development, they would say demo at the end of the sprint. I beg to differ. The reason is demo is a dog and pony show. I can show you nice things and you can sit there and say, oh, that's good. Can you change the color on that? But that's not really the feedback I really want. So I'll relate to one of my early experiences. This was before the time that agile development was coined as a term, agile development. And I was working on a project and my boss called me and said, I've got a good news for you. And I'm like, ooh, what's the good news? And he said, we got a brand new project we need to work on for our company. And we decided you're going to lead this project. I said, this is great. Thank you. What can you tell me about this particular application we're going to build? And he said, it's due on November the 1st. And I said, that's good. What else can you tell me about it? And he said, it's due on November the 1st. And if you miss the deadline, you are dead. And by the way, when he said that, you got to realize this was in Texas. So when they say you're dead, they actually mean it. So I had to be very careful about it, right? So I'm like, well, that was very helpful. What about the requirements? And he threw a document at me and said, go read this. And I read that and I understood nothing of it. And there was 15 pages of it, 7 pages of legal stuff, and other 7 pages of technical things I don't understand. And I'm like, what do I do? How do I succeed on this product that we're going to develop? And to me, it was extremely important that we succeed. So I called my client and I said, hey, I am the guy who has been assigned to your development. I'm going to be building the software. I'm going to lead the effort, but I'm going to be mostly the developer on this product. And I just wanted to say hello. And he's like, yeah, thanks for reaching out. And then I said, I really want to succeed in this product. There was a long pause, and the guy on the other side said, well, that's refreshing to hear. I would like also you to succeed. That would be a good idea. And then I said, but here's what I want to do to succeed if you would work with me this way. And he's like, what do you want to do? And I said, well, I'm going to give you a version of the code, the binaries, obviously, but I'm going to send it to you every Tuesday. And what you need to do is by Wednesday morning, you need to send me 3 things. You need to tell me what you like about it. Always good to have a good, positive feedback. I want you to tell me what you want me to improve from here on. Not a negative, oh, this sucks, but tell me what I need to improve. So what do you like, what I need to improve? And what should I focus on based on what we have so far? What should we focus on moving forward? And he said, that's not the way we do software, but you know what, we'll try it. And every Tuesday, by clockwork, I would send them the binary and say, here you go. And they were so thorough about it. Within 24 hours, and often the same day, they would send me the list of what do I like, what you need to improve, what you should focus on. Now, the beauty of this was that they were actively using the application every single week as I was sending it to them. So the feedback I was getting was not from a demo, but by an active use of the application. Now, the funny part of this was we were taking about 6 months to develop this, and we were sending this every week, and we actually got this done a couple of weeks ahead of time. And a good 2 months went by, and a lady came and knocked on my door. Haven't seen her, in the company I worked in. And I looked at her and said, hello, hi, what can I do for you? And she said her name and said, I'm from accounts, receivable, and are you? And said my name. I said, yeah. And she said, well, looks like you're in trouble. I said, oh my God, what did I do to cause trouble for you? And she said, well, our contract says that you will release the product on a certain day, and we get paid 50% when you make the release. And then you are supposed to fix all the bugs within 60 days. And then after all the bugs are fixed, we get paid the other 50%. And our record shows you haven't fixed any bugs, so we are not getting that other 50% paid. We need to answer to the corporation why you failed on your job. I said, oh my gosh, I was so worried about it. Thank you for letting me know we don't have any bugs to fix. And I heard the biggest laughter anybody can have. And then she said, oh, that was a good joke. We always have bugs to fix. And I said, well, that's the problem. We shouldn't. And we don't have any bugs to fix. I was like, no. Let me explain to you. I'm like, no, you don't need to explain it to me. And I called the guy on the other side and said, hey, I've got my accounts receivable, want to talk to you if you don't mind. And I gave the phone to her. And she's talking to this boss on the other side. And he's like, oh, yeah, we got the software 2 weeks ahead of schedule. We've been happy with it, and everything is working great. And she's like, but what about bug fixes? And he's like, what bug fixes? We've had it in production for 2 months now. It's working great. And very reluctantly, she hangs up. This cannot be true, can it be? Right? And the point is, you don't have to be fixing bugs, because when you put things into use very early on, the feedback begins to come early on. And when the feedbacks are real feedbacks, you can fix the things very early on. You don't have to wait. But if you don't give the product early on and you keep doing demos, and then you give the product, and for the very first time people start using it, that's when you start getting the real feedback. So accelerate the feedback loop very early on. And to me, it is also that agile development is about adaptive planning. So it is about adaptive planning. If everything is set on stone, if you have decided on the date of the release, if you have decided on the scope, you have decided on everything, what is there to be agile about it? So that's basically a pathway to disaster. So you need to be adaptive about your plan. And what that means is you need to look at where you are right now, and you want to make changes based on either the realities of the scope or the time, and you got to keep making adjustments to make sure that we are arriving someplace reasonable where we can still provide value for what we are doing. So this really becomes the fundamentals of what we really want to do when it comes to agile development. So how do we actually achieve that? Now, one of the things to really think about is that when you are developing software, you want to ask the question, how do we keep the software releasable at all times? Now, you would be surprised, and you probably have seen this quite a bit. I'm a consultant, so I go into different companies, and I work with the teams to improve what they do. But I'll tell you, I am in some random part of the world. I am sitting in an office in London, for example, or I'm sitting in an office, let's say, in Oslo, and I'm asking a question to the developer, hey, you said you want to fix this problem. Why don't we take a look at the code? Why don't you fire up, run the application, show me that particular area of the code, and then let's talk about how we can improve it. And when I say this, you will be surprised how many times the programmer looks at me and says, oh, Venkat, you got to give me a few minutes. I need to get this ready for running. And I'm like, okay. And I'm sitting there for 20, 30, 40 minutes sometimes when they're doing something or the other so they can get this code eventually ready to compile. And I'm always thinking, how much time and money are we just wasting just waiting for that? And I would tell them, why don't you just put this away and pull the code from the branch? Oh, no. I can't do that right now. There are reasons for it. Well, the point is, I want the code to be releasable at all times. And within seconds, I should be able to, bring up the code, execute it, at least be able to release. That's extremely important. But what makes it impossible for us to make the release from time to time? And this really goes back to certain things we tend to forget or ignore. Now, you may ask the question, how do things become so bad? Well, it's not because we sit there and say, I want to make things worse. And we make things bad because sometimes as time goes on, we lose the sense to know that things are really bad. And to draw an analogy to that, right? If you look around, so I'll give you an analogy for this. I was in a company doing some training, and as you kind of have noticed, right, I like to pace around when I'm talking. And in this company, I was in this training room, and as I was pacing around, I would kind of do this. I'm like, whoa, what's that? And I would look around, and that's when I noticed this place where there was the little area for me to teach, and this was filled with monitors. And I'm like, wow, look at those monitors. And then I kind of looked at the team and said, that's a lot of monitors. And one guy said, yeah, they're all broken, they don't work. And then I started thinking, how could this have happened, right? So there was a time when this training room had a beautiful empty floor. They could mop it, they could clean it. And one guy had a failed monitor. And he's like, this monitor is broken, what do I do with it? Well, you got to find a place to put it. And they're like, where do I put it? Oh, why don't you put it in room 107? 107? What's that room? Oh, that's a training room. Nobody's using it. Great. So he puts it in the training room. The first day, there was one monitor. If you had a camera, you can watch on it, right? Empty room, one monitor. 2 weeks goes by. One of his colleagues breaks a monitor. Hey, where do I put this monitor? Oh, that goes in room 107. Immediately, right? Oh, really? What is room 107? Oh, that's a training room. That's where we put the monitors. And 15 monitors later, hey, I've got a monitor that doesn't work. What do I do? 107. Hey, what is 107? That's where monitors go to die, right? And all of a sudden, this became a monitor graveyard. And you're like, how does this happen? It didn't happen overnight, but it happens one step at a time, right? So if you ask me, I have this noise detector. That's what I tell people these days. I got this noise detector. The first time something is, a little odd, the little alarm goes in my mind, like, I'm like, no, don't do this. For example, very simple question, you know this answer for this, right? I want to save a file. Where do I save it? You know it. Come on, say it. Desktop, right? You've all seen desktops, right? And I will know how to identify a genius. Because when they show me the desktop, there's only 350 files on it. And I always admire them. How do you find the file you want? And somehow they do, right? And that is the thing that is the weirdest for me. This is my desktop, by the way, honestly. That's exactly my desktop. You can count the number of files on it. And the question to me is, if I put stuff on the desktop, what does that mean? I have zero way to organize my files. Where I put my file, there's a software term for it. We know what that is, right? It's called cohesion. Cohesion is not by writing code. Cohesion is in everything we do. So there's no separation of concern. And when I need to find something, desktop is the most weirdest place to start looking for 350 files in it. So the very first day, I realized, why would I dump everything into my desktop? That doesn't make any sense to me. And so that's the noise detector I was telling you about, right? And everything I do, I try to find a purpose for it. Right? Live with intention and be deliberate about what you do. And when you do it, you're removing this clutter, you're removing this noise from you. And the same thing, this really comes back to this beautiful idea called the broken window theory. So the broken window theory, how did this room 107 become the monitor graveyard? Well, the reason it became a monitor graveyard is somebody dumped the dead monitor on that room. Now imagine this happening in a company, right? I worked in companies where we've had assistants who are extremely opinionated. It's wonderful when you have people like that. And they would hunt you down if you do things that are going to become messy, right? So this assistant in the department would come around and say, I saw a monitor in room 107. I want to know now who left it there. And you're like, oh my gosh, I got to go talk to her again, right? And she is like, you don't leave stuff around there. You have something to put, you come talk to me. I'm going to tell you where to go drop it. You don't just drop things around anywhere and walk. What if I come to your office and drop things and go away? How do you feel about it? You're like, okay, sorry, ma'am. I'll make sure it's in the right place the next time, right? So the point really is that person is not going to tolerate. But I'll tell you, this really comes down to two things. A, fundamentally, you should care about how you do things. Second, you communicate to people around you that you don't tolerate people trashing things. This is really where the culture comes in. I'll tell you one thing I will never forget. This was years ago. I had a colleague of mine who was at least that high compared to me. I'm like a little chicken when I walk next to him. I'm a short guy, and he is really, really tall. And we both are walking on the campus, and this was at the university at the time. So walking on the campus, and there was a fine young gentleman sitting on the side, and he decides to finish a can of soda, and he's taking an aim at a trash can that's across the pathway. And we are walking, I'm seeing this guy do this, and he's kind of taking the aim and throws it, and the trash, and the can, soda can, empty soda can, goes and hits the trash can and bounces off and falls on the ground, right in the middle of the path. So as we are walking by, now that can of trash, the used can, is right in the middle of the path, right? And as we're walking by, I could never do this because I don't have the height to do this. And my colleague just thump stops. And I'm like, whoa, he stopped. I'm going to stop next to him. And he looks at this guy and says, hey. And the guy is like, who are you, right? And he looks up. He says, question for you. He's like, yeah. Do you want to get up, pick the trash, put in the trash can, or do you want me to come and get you up, and so you can pick the trash can and put it there? Your choice. And the guy's like, oh, I'm really sorry, sir. I'll take care of it. And he gets up and puts in the trash can. And I'm like, that's what we need to do, right? So first, hire a tall guy on your team, right? And the second is, and the guy goes around and says, you don't trash things around here. Now imagine how things change when you tell people that you don't trash things around me. That's a culture, isn't it? And when you create a culture where you say, we're going to have things clean around us. You can look at the stage. Nice people, they didn't trash anything. And as a result, there's a nice place to walk. You're not going to cause a hazard here. And the same thing applies to our source code as well. But how do you know that things are working? So this is where the broken window theory comes in. This was a study back in the last century, somewhere in the 70s and 80s. And a gentleman named Philip Zimbardo was curious about how to really avoid dysfunction in a lot of different things. And he said, visible sign of disorder accelerates disorder. So when you see something, right? So imagine this for a minute. You look at a code base, and the code base is beautiful, nicely kept. Files are in the right place. Variable names are really nice. And you have good function names. And the day you sit down to write code, if your guilt is going to kick in, right? You're like, I don't want to be the guy who wrote that bad code in the system. But if nothing compiles, there are only 720 warnings. Why? Because they're only warnings. We don't care about it. And if something doesn't work, how does your mind respond? It's just one more thing that doesn't work. What's a big deal, right? So we view this very differently. So this is the idea of the broken window theory. So what he did to prove this particular hypothesis is he wanted to prove that this disorder leads to deterioration of the environment. And intended to, show this is true, what he did was he did a study in New York, and they took a really nice car, and they parked the car in the corner of the street, and this was done in conjunction with the police department. So the police sat at a distance, and they were viewing this car through their cameras. And this car was in the corner of the street, nice clean car, everything was great, and the citizens of New York would walk by and, hey, kind of nice car, isn't it? And then they're just walking around. And a few hours went by, nobody's messing with the car, but they're making note of this car. Hey, nice car. And so one of the cops went down and broke one of the windows in the car. and then went back and sat down and started observing. And a few minutes goes by, a citizen of New York walks by. Hey, nice car with a broken window. And whistling around, right? And there's nobody around. Well, if your car window is broken, if you're nearby, you're going to be kicking and screaming, isn't it? So if there's no scream, what does that mean? The owner is not nearby. I mean, seriously, a car with a broken window, does it really need a stereo system in it? So he helps himself with it. And within a matter of hours, it was torn apart and destroyed, shredded, so to say, right? So the idea is that if something is deteriorating, it will keep going bad over and over. But if something is really good, you don't want to put a stamp on it, say, I was really good until I came along, right? So as a result, you'll maintain that with good quality as well. So and this is a good idea, but unfortunately, a lot of these good ideas don't work always. And sadly, in criminology, this led to a lot of negative practices. This is related to policing and profiling, stuff like that. We don't need to talk about it right now, but we can at least take those ideas and gain from them in our field. This is where continuous integration really comes in. So what is continuous integration? So continuous integration is really based on the broken window theory. And that is, if something is working, you want to make sure it continues to work. And if something is not working, then the utmost priority is to make sure it works. So to make it releasable all the time is one of the ideas. Now, you may say, why should we really do this? Now, this really goes back to culture, right? Because you want to value the time of yourself and your colleagues. If your colleague pulls a piece of code, and if the code doesn't work, who's going to waste their time trying to make that code work? That's everybody who gets the code. And when multiple people waste their time to get the code to work, that's really poor efficiency on the part of the team, loss of money and revenue from the time we could have used better as well. So you're very sensitive to people wasting time, and you want to make sure people are able to continue moving forward. And in a similar way, this is not just about code being broken, right? The good friends who raised the hand for JavaScript earlier, if I install a particular package on my machine manually, and then I push the code, and I go to the dentist office for the rest of the afternoon, you pull the code, it doesn't work anymore, and you're like, what did Venkat install? And then what version did he install? And you just wasted 20 minutes trying to figure out. That's a lot of lost time and effort, isn't it? But if you have a continuous integration, well, I manually installed it. I push it to CI. The CI build breaks, and immediately we know that you didn't really commit the changes properly, and you need to update the package JSON properly and say what needs to be installed. So when a colleague of yours pulls the code, it's going to be ready to execute because it installs it properly already. So this really comes back to the avoiding the loss of time and loss of efficiency, if you will. And also, software begins to rot over time. And when software rots, you want to get quick feedback when things work and things do not work. That becomes extremely important. So there are multiple reasons for us to be able to do this as well, for us to be able to benefit from this. And don't be episodic in your integration. It's very expensive, very slow, and it's very error-prone. A case in point, I once joined a company where they were developing software, a second version, they said, a second version of their software, and they've been at it for about 3 months on the project when I joined. And they brought me in to move things forward because they were not making good progress. And I said, hey, I'm new to this project. I want to know what I'm doing. And I said, I hear that you're developing the second version. That's great. And how do I run the entire application? You'd be surprised at things you hear sometimes. And they said, oh, no, 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 no. We are building only the features we need for the second version right now. And then we're going to integrate this with the first version before we go into production. That's a noise detector in my mind, right? And immediately the sirens go in my mind. And I look at them and said, whoa, that scares me. Who here has at least done one integration? No hand went up. And I looked at the boss and said, would you mind if I spend an hour or two this afternoon just compiling the code for version 1 on my machine and writing a little bit of code to integrate with it? And he's like, yeah, go for it if it's going to help you to familiarize things. And I did that. And the next morning when they came in, I said, I got a bad news for you. If you want to integrate the code into the first version, you need to have these set of classes that you extend from, and none of the classes you're writing right now are doing it. So what that means is you finish the second version features, and then you start making a lot of code changes for you to integrate. Who wants to do that? And they're like, oh, we didn't know you have to do this, right? So they had no concept of what it takes to integrate. And you'd be surprised when such things happen, but I've seen those scenarios. So the first thing we did was to start integrating into the code base and start building it as one integrated system. But if you have a CI build and you start pushing things to what exists already, you start getting feedback very early on. So continuous integration is a way to get early feedback. So the first recommendation I have is integrate early, integrate often. But you say, gosh, Venkat, we do CI build. That's old story for us. What can we do differently? Well, that's the first step. So to have a CI build is very important. Now, the questions people often ask me is, this is a great idea, but I work in a very, very small team. And sometimes they say, I'm in a team of 1. We have only 1 developer for this particular project. So I don't need CI for this, right? And my answer is, oh, yes, you do. So I work on a code base where I'm the only programmer on that code base. But guess what? I've got a CI build. And you may say, really? Why do you need the CI build? Well, there are a few reasons I need a CI build. I'll talk about a few reasons later on, but I'll give you one reason. And that one reason is my code has to my application has to communicate with a third-party service, which provides a very critical financial functionality. Now, that's a third-party service that's running in a remote server that's provided by this third-party company. And if my code communicates with their code at runtime, and if something fails on their side because they upgraded something, my application is going to fail. And if I know it failed in production because I get a support call, to me that is too late. So here's what I've done. I've got a CI build of the single-man project, and my CI build runs every 15 minutes. And it runs an integration test every 15 minutes. Why? Because every 15 minutes, I want to know my code is able to integrate with this third-party financial application really well. And I put the CI build, forgot about it entirely. And I have it set up so that if a build were to fail, it will immediately send me a text message on my phone. And as you probably have noticed, I always have my phone with me when I give a talk because I run my timer on it. So I have the phone with me. I'm giving a talk in a conference in Riga, Latvia. I'm in the middle of my talk, and suddenly I get a text message saying my build is broken. The rest of the talks was horrible, by the way, because my mind is like, my build is broken. I don't care about this talk I'm giving anymore, right? At least in my mind. So I finished my talk, and the first thing is, I got to run. And I literally rushed, and this was a conference where the first floor was the conference area, and the sleeping rooms were in the same building. I rushed to my room, so I can check what's going on, right? And thankfully by then, before I could even look into it, I got a text message saying, build is passing. I'm like, oh, I didn't have to do anything. But of course, I was curious why that happened. I started digging in. And that's when I found out that the third-party financial company that provides that service decided to make a change to the service that broke the contract. And then they realized their mistake and they rolled back the change. But I was like, not bad, that my system was able to proactively alert me when that build was failing because the integration was failing. So to me, I care about these kinds of stuff because I want to be proactive in knowing when things were to fail. I don't want a user to report a bug or an error in my support system. That is too late for me. So even a single person development environment, it makes sense to have a continuous integration. But that's just one reason. There are more reasons. I'll talk about that a little bit later. But having said that, we definitely want to avoid a cult-like following. In general, for most of the things, a cult-like following is not a good idea. So sadly, much like the broken window theory, this led to some negative practices. Companies started doing really silly things. I've heard about companies using what's called the shirt of shame. A shirt of shame is, if you break a build, you get to wear the shirt that says, I broke the build. And at some point, we have to keep in mind, these are not healthy habits. It may appear funny in the beginning, but not everybody in your team may find that really funny, to be walking around the campus with a shirt that says, I broke the build. So we need to be very careful not to intimidate people, to shame them for what they do. It's natural, it's okay. Hey, if somebody broke a build, don't give them a shirt of shame. Pair with them and find out why the build is broken so you can educate yourselves first and then help them to learn one or two things also along the way. That's a much better way to work with it. And this leads to fear of breaking the build if we cause these kinds of shame. And that leads to fear of change. So you're like, whoa, I don't want to take the punishment for breaking the build, so I'm going to delay it. Why? I just get punished once for all the changes, right? Rather than making multiple changes, be punished multiple times. So this leads to negative behaviors, if you will. And the progress will become slow, and you're going to have a low morale in your team as time goes on. And we totally lost perspective as to why we are doing this. So this becomes a misplaced objective. Rather than having this used for the right reasons, this becomes used for a wrong reason. So be positive and encourage people to do things for the right purpose. This also reminds you of one experience. When you look at a failed build, you shouldn't get offended by a build that fails. The people are weird sometimes. They take on wrong things and get angry about it. I was talking to a team, and they implemented the CI in their project. And guess what? When a build failed, the team got an email notification. They got angry because they're being alerted of a build failure. So you know what they did? They turned off the CI build because they don't want this notification anymore. And you're like, really? If a build fails, the solution is not to kill the build system, right? And they're like, we're done. No longer it will make any noise anymore, right? And so this, again, I would argue is the noise detector. And how does this come to this point? When you see an alert, your mind should say, wait a minute, why did I get that alert? Let me find the source of the problem, and not to ignore the alert and then say it flooded the mailbox with all these notifications, right? Or my SMS is being flooded. So that is something we need to really take the time to understand, so the team is using it for the right reasons, for the right purpose. So what are the benefits? The first benefit is it reduces the risk for us. So what is the risk it reduces? Well, it reduces the risk that maybe the code doesn't even compile, and we may have to spend a lot of time and effort to compile this code again. Now, why would this happen? Well, there are parts of a system oftentimes that you may not really actively be building on a development environment. And if you don't build something for a while, what happens? You tend to forget the commands you would use. The system may become obsolete. You may upgrade a few libraries or packages, and nobody has compiled it for a while. And one fateful day, the boss comes to you and says, come on, we got to make a change to this right now. And you're like, this doesn't even build anymore. I've seen this in companies where somebody who wrote the code and built it no longer works here. And that code is sitting there. And they come to you and say, we got to fix this now. And you're like, I don't even know what to do to run this code. And the boss says, oh, don't worry about it. Before he left, I asked him to write the documentation. This is when I begin to cry. Because you know what happens? You take the documentation and none of the commands in it work anymore. The documentations are like a dead rat, right? Because it says, run this command not found. Like, why, right? And this is the stupidest thing I've seen people do. I hate such documentation. And on a system where I worked on, this is exactly what happened. And my boss came to me and said, here's the documentation he wrote before he left. Run this, fix it, and release it. I want this afternoon. It's like, thank you, but it's not going to happen because nothing he has written is working. Oh, but he verified before he left. Yeah, it worked at that time. But why would it work now? So to me, I want executable documentation. This is exactly what I did on the project. I told my boss, I'm really sorry. He said, okay, do me a favor, update the documentation. I said, why? Are we not learning anything, right? This is what Einstein said. Einstein said, doing the same thing over and over and expecting a different result the next time is the sign of insanity. He wrote the documentation, it doesn't work. So you go update the documentation. Oh, why would it work now? Right? I can update it, what happens 6 months from now? So I said, boss, I'm not going to do that. I'm going to turn this into an executable documentation. And he's like, what does that mean? Well, I'm not going to write a Word document. I'm going to write step by step. It'll echo what it's doing, and it will run the command. And it will take the output and analyze it, diff it. And when I write this document that explains how to build it, I'm going to put this as part of the CI. And that's going to be running every time. So as a result, if any day it doesn't work, you get a notification right away. And you can fix it on that day rather than finding it doesn't work 6 months from now. So to me, it reduces the risk when you start running things periodically. And to me, the ability to know it is running now and I can make changes to it is far better than saying it worked once upon a time. We don't know if it'll work today. So it reduces your risk. It reduces the cost of running these systems and maintaining these systems. How does it reduce the cost? It reduces the cost in multiple different ways. One of them is, think about it this way. You are in your office, right? And when you're in your office, you are having a good time talking to your colleagues. And as you're talking to your colleagues, you took the key on your hand for reasons you don't understand. And as you're talking, you drop the key on your table. And you don't even realize it. And then as the day goes by, it's time to leave. So you shut your door and you walk all the way to the car. And when you get to the car, you put your hand in your pocket or in your purse, and you're like, wait, where's the key? And you realize the key is in the office, but you just closed the door, and you realize you cannot go back in. And you got to call somebody to come and open the door so you can go in, and you can't leave this place for another hour. And you kick and scream at this point, right? But when did the problem start? The problem started when you were in the middle of this discussion and not realizing you took the key and you dropped it. But when did you know that this is a problem? Not at 2 in the afternoon, but 7 in the night when you're ready to go home is when you're like, oops, where's my key? And there was a good 5 hours you didn't realize, and now it's expensive because you got to wait for somebody to come and open the door, and you got to wait here out in the in the lobby, right? On the other hand, if you take the key and drop it and you walk away, what if it beeps to tell you, hey, you're leaving the key behind. Did you mean it? And you're like, oh, of course not. Thank you. And you can take the key right away. So the point is, you're reducing the cost. You're able to find the bug or the error and fix it soon after it happens, and not when you eventually discover by manually running into it. So it reduces the cost a lot for us. It makes the code releasable all the time. That is something I care a lot about. I must be able to release the code anytime I want to, and to make it releasable is to really make sure it's all compiling, tests are running, and it's ready to be given out if I need to. It reduces the bus factor. So what is the bus factor? The bus factor is the number of people on your team that should be run over by a bus for your entire project to fail. Can you imagine what that number is on some projects? 1. If one person, and this actually happened on a project. This was not a bus though. This person won a lotto. And he's, I'm rich, I don't have to work anymore. And now we couldn't even build the system anymore. We would have been happy if it was run over a bus than win a lotto, right? And how could we get to that situation where there's one person who knows how to do this, the rest of us don't know it? And that's a very high risk, isn't it? And how can you mitigate that risk? Well, make that process as part of the continuous build. So we can look at the script and know what to do. It's not a secret this person holds. I know how to run it. I will not tell anybody else, right? So put it out. So it's easier. You're reducing the bus factor. It promotes automation. CI is the first step that you have to pass before you can go towards continuous delivery. So you cannot do continuous delivery if you don't have a continuous integration. And of course, it's hard to do continuous integration when you don't have the discipline to also get the feedback through other means like automated test. It's got to have something to give you feedback on. So this promotes automation quite a bit. But there are things you need to do in order for you to make good use of this. And one of them is the knowledge that difference makes difference. I'll give you 2 examples of this. Lessons I've learned the hard way. One in a nice way, one in a not so nice way. The first one that's not in a nice way. This was a project where we did not have CI. And we did not have CI. We were not as mature at that time. And I had written a piece of code, and remember the infamous phrase, right? It works on my machine. And I tested it. It worked on my machine. And to my credit, I had a fairly good amount of automated test. We just didn't have CI, but I had written automated test. And I ran my tests. Everything was passing. And I'm going to date myself here. This was back in, I think, 2003, 2004 timeframe, right? A good 20 years ago. And I was like happily going around when my colleague came to me and said, oh, Venkat, your code doesn't work. I'm like, what do you mean my code doesn't work? Because I'm this guy with confidence, right? I've written test cases. And he said, your code doesn't work. I'm like, show me what doesn't work. So I walk up to his machine. And he runs the program, click, 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 and boom, error, failure. I'm like, wow, yeah, it is not working. I'm surprised. And I said, hang on a second, I'll be right back. And I run over to my machine. And I run all my tests. And all my tests are passing. I'm like, okay, I was hoping my test would fail, but it didn't. So I'm not sure what's happening. So I go back to him and said, so you're saying it doesn't work and it's my code that's not working, right? Oh, yeah, look at the error, it's coming from your code. And then I said, oh, I got a question for you. Did you run my automated test on your machine? He's like, no. Well, let's run it. And so he runs the test on his machine. And sure enough, some of the tests are failing on his machine. And my first question is, hey, what's special about your machine? Because those tests are working on my machine, why is it not working on yours? And that's when we found out we both were using two different versions of Windows. And I'm like, wow, you're using that version of Windows. I'm using a different one. You know what? I'll take a look at it. I'll get back to you. Thanks for helping me to find this. Now I'm going and scratching my head. And I'm not kidding with you. I go into the documentation and I'm in complete disbelief. The code I had written, which works on my machine, I'm looking at the function I'm calling, and the documentation from Microsoft says, one single line, standalone line, this does not work on Windows 2003. I'm like, wow, why would you have a function that doesn't work on one operating system? And why is he using that one? But the lesson I learned the hard way is difference makes the difference. And I learned my lesson. And the lesson I learned was, if your product should run on different versions of operating system, make sure your CI builds are for each one of those versions. If your company says, this product should run on these 3 versions, you better make sure you have CI for those 3 versions, right? That's very important, very critical to have. That is something you need to do because difference makes a difference. Fast forward, I was on another project. We had CI/CD at this time. And in this case, my colleague commits a code. Obviously, it passed on his machine, but it failed on the build machine. And we are like, wow, why does it fail on the build machine while it's passing on your machine? That's when we found the database being used on the build machine was different from the database being used on the developer's machine. But the product needs to support the version of the database that was on the CI machine. And to know that your code may not work in one version of operating system or one version of database, but will work in another, when do you want to know that? The worst time to know that is to get a call from production, isn't it? But you're able to find this during development. So the moral of the story is, you shouldn't have one CI environment. You need to have multiple of those. And you say, oh my gosh, wouldn't that cost money? Yes. But when it doesn't work, when your programmer spends 7 hours trying to find out what went on, that actually costs you more money. And so it's actually a cost saving. And different versions of libraries as well, we should be very careful about. So the cost of finding and fixing the problem goes up as time goes on, right? So think of the cost, overall cost, not just the cost of just putting that alone. And you say, okay, that's all right, but when a build fails, if I have 7 environments, and if the build fails in 4, I get, boom, bombarded with 4 emails or notifications. That's nasty, isn't it? Oh, I agree. But the key is to get feedback as soon as possible. So stagger these over time. Let on one primary platform, let it run immediately. The others can be phased out. Let them run 15 minutes later, 20 minutes later, 20 minutes later. So if one fails, you can immediately know that one failed and you can act on it rather than being bombarded by all of them at one time. Of course, there are several tools available that you can use. I'm not going to be spending the time here on the tools. Find the one that works the best for you and make use of it. So essentially, in this case, run it as often as you can. How often? Every day. Every commit is good. If not once a week, if not once a day. Again, I'm not going to be, about exactly this is how you should do it. Find what makes sense on your project. And what are the things you would do typically? If a compilation is needed, make sure you compile all the code. That's typically languages like Java and so on. Run your automated test. Run your unit test. Run your test with dependencies using stubs, mocks, what have you. Run your integration test as well in this environment so you can get feedback on how these things integrate also. Use fakes to make your integration tests run faster so you can get continuous feedback on those as well. You can run your contract testing on these as well. So the more things you can get feedback on, the much better it is over time, and you're able to continue with these things. So rather than being, adamant about it, rather than being, with the mindset to punish people for failing build, leverage it for the essence of agile development. And that is, to me, feedback-driven development. And get feedback from different environments. Get feedback from different steps in your pipeline. Get feedback about how your colleagues are able to push the code and get the integration going, and use that to your greater benefit. And the goal is to actually use the feedback to build better software and not to go around punishing people. That's the whole idea. Hope that was useful. Thank you.